The inverted pendulum is a classic unstable problem in dynamics and control theory and widely used as a benchmark for testing control algorithms. In the Furuta pendulum, motor speed is controlled to balance the pendulum vertically upward. Two sensors encoders are used, pendulum angle and motor angle. In this example, we will apply model-based design to develop and prototype a control system that will swing the pendulum from a vertically downward-facing direction to an upright position and maintain it as disturbances are applied. There are three requirements on alpha. First, upright balance is maintained for impulse angle disturbances up to plus or minus 10 degrees. Second, the pendulum swing up is completed within 4 seconds. And third, the pendulum swing up requires 5 cycles or less. These requirements are represented in the following design model.
The design model is simulated to illustrate the requirements.
In this step, the swing up and balance controllers are implemented and simulated with the plant model for a 20-second real-time period. The requirements from the design model are plotted along with a pendulum angle in the upper plot, and the motor angle is plotted in the lower plot. Focusing on the upper plot, we see the swing up controller required 3 cycles to reach the balance point and did so in about 2 seconds. At 6 seconds, a 5-degree alpha disturbance is injected, and at 12 seconds, a 10-degree alpha disturbance is injected. And we see the balance controller maintaining alpha within the required plus or minus 10-degree range.
Moving to the hill phase, the simulation controller model is modified for hill deployment by removing the plant and motor models, adding a sensor processing block, and adding an actuator processing block. The controller code is configured to run in real time and executed on the target pendulum hardware. Alpha disturbances are injected at times 6 and 12 seconds, and we see that all design requirements have been satisfied. The model-based development method has enabled us to go from requirements to implementation in a repeatable, efficient manner, satisfying all requirements with minimal work.